When a product team receives pull requests from some central team, they view it kind of like unwelcome advice coming from an in-law. Most people that start thinking about large-scale change, the most natural thing for us to think of as developers is pull requests or mass pull requests.
Does this then start creating pull requests in every single project? And then who then goes about merging all of those pull requests in unison?
I think we've identified over the years the room for something we call pull-based change and room for something like, you actually use the right word, push-based change. They're just looking for a reason to reject it. And so we really focus a lot on how do we put the problem in front of a developer in the kind of IDP sort of way, like here's where you're at relative to an objective, but it's meant to be informative. And here's the button. At a moment in time of your convenience, this recipe is ready for you. And we got you 99% of the way there, 95% of the way there, whatever the case might be, do it. And so what you'll see is individual product teams doing pull requests to their subset of the business. And that has a much higher acceptance rate than centrally issued mass PR.
Hello and welcome to another episode of the AI Native Dev. And joining me today is Jonathan Schneider, who is the CEO and co-founder of Moderne. And Moderne is a company that is really focused around the analysis of code and also the refactoring of code bases. So welcome, Jonathan. How are you?
Doing well. Thank you, Simon. Glad to be here.
Oh, absolutely. Pleasure to have you. And whereabouts are you calling in from today, Jonathan?
I'm in lovely Miami, which was one of the best moves I made a few years ago, coming from the West Coast to Miami.
Oh, wow. Over on the San Francisco Bay Area style?
The company was actually founded in Seattle, which itself is an interesting accidental story, but, founded in 2020. The first person we hired was in Seattle. So I just up and moved to Seattle, and we worked in parks on a bench for the first little while. But after a couple of years, kind of moved over here to Miami, where it's much better for time zone and weather, as you can imagine.
Oh, absolutely. Yeah, the connection to Europe and other places, I think from a time zone perspective,
much easier,
very much more convenient. And I relate very much to the Seattle weather being in the UK.
So of course.
Yeah. So yeah, I kind of mentioned Moderne, it deals with the problems that developers have about refactoring, about rewriting existing code. And tell us a little bit about from your point of view, what was the reason you created Moderne? What were the biggest problems that you were trying to solve at the time? And how old is Moderne as well?
The company itself is nearing 5 years now, but the technology OpenRewrite that goes behind it actually goes back almost 10. I was working for Netflix engineering tools and in some ways somewhat responsible for shepherding the organization through large-scale changes at the time, like Java 6 to 7 and trying to get off in a logging library and these sort of things. And while, I spent a lot of effort and a lot of my team spent effort on trying to provide things like early internal developer portals, like basically dashboards to show people where they are relative to where we want them to be, we found that it resulted in approximately no action towards the objective. And so just interviewing those teams, those product teams, and saying, what would it take for me to move you from one thing to another? They would say, well, do it for me. Otherwise, I got something else to do, right? And it's true. They had a ton of feature pressure on them. So these kinds of efforts were always back burner, right? Not top of mind if they weren't required. So, so the framework started then to try to literally do it for them, try to provide ways of automating this change. I had gone on to the Spring team, founded a project called Micrometer. So completely unrelated, started working on a product called Spinnaker, which is also open source out of Netflix for advanced continuous delivery. And our co-founder, Olga Kunzic, and I were working with a lot of the large banks and retailers and so forth, trying to build advanced continuous delivery concepts. And, they'd say, talk to me in a year when I'm done moving Spring Boot 1 to 2 or this to that, and so it's just kind of like we got pulled into this by seeing how repeatable and ubiquitous this problem really was.
Yeah, and the value, in terms of the value of people, doing a lot of the rewrites and I guess things like that, what would you, when you're talking to developers and developers like, I've got a ton of things that I need to get done, what would you provide them as like, this is the reason why this is important and why you should, consider this high on your list of things to deal with?
I think luckily it already is high on the list, and we hear in various different ways. This is roughly 30 to 40% of just total engineering time. It's just
Mhm.
keeping the lights on. You're using an open source third party thing. It makes a change to its API. Like you have to continually restitch the application or it ceases to function. So it's just a reality of software development. And the more net new code that we write, the harder that problem becomes.
Yeah.
Really.
Yeah. And it's one of those things that I guess it's considered almost like technical debt. Some people kind of want new features from a framework, which is only available in a new version, but it's just general good hygiene, good software hygiene to maybe not bleeding edge, but very often stay high up with the nearer the latest. For
One of the
software.
more evolved ways of thinking about this, because you mentioned technical debt, actually comes from shelter insurance. Kind of a mid-sized property and casualty insurer in the mid-US, they actually tag technical debt on their backlog differently from maintenance. And I think that's a really subtle distinction where, we used to think of technical debt as something where I took a shortcut and I'm going to have to pay that down later, but it's really, I chose to do that. And I really identify with the developer position right now, which is that I could make all the best architectural choices, the best language choices, the best library choices. I could be absolutely perfect right now, today on July 15th. And, 6 months from now, that thing is shifted. So it is really more like maintenance that you have to do on a car or a house. If you don't do it, you can't expect the thing to continue to function.
Yeah, no, absolutely. In the era of AI, I guess there's a number of tools that with pure LLM can kind of like do some of this. They can understand and somewhat analyze code bases. They can make changes. They can do a number of things that even somewhat reasonable at completely changing language from one to the other. What would you say? I guess from the pure AI point of view, are the advantages and maybe some of the things that they're not so good at when thinking about any kind of maintenance or framework changes, keeping up to date, that kind of thing.
Yeah, I think broadly, I would consider AI based or pure AI based solutions to be concentrated around authorship experiences. And by authorship, I mean I've got one repository open in the IDE, or I've got a CLI based tool like a Claude Code pointed at a particular repository, and I'm asking to do a thing. And that thing might be a feature development. It could, of course, be like you say, language to language, whatever the case might be. But there's going to be, a degree of time it spends on that one repository.
Mm-hmm.
Maintenance type activities or modernization type activities tend to be cross-cutting, and at most, I'd say even mid-sized customers of ours, we're dealing with hundreds, thousands, sometimes tens of thousands of repositories. So that workflow of like CD to a directory, say Claude, ask it to do something, commit, clone the next one, CD into that directory, Claude, commit, just doesn't really scale to the problem.
Yeah, because I guess if you have an enterprise scale app and you want to make a change to a framework or something like that, you probably have a vast number of files that need to be adapted. How good would you say AI tools in general would be at increasing their context windows to be able to take in a number of more projects, more files? Is the limit then the context window itself? Does the LLM you find get a little bit more confused the more context you throw at it? Or is it kind of just the experience of, well, how do I even pass all of this if this is spread across hundreds or thousands of repos? What would you say are the limiting factors?
Right. Yeah, first of all, increasing context window does come with a trade-off, and that's that there's this inverse relationship between context window and the attention mechanism that's fundamental to LLM. So you would expect, as context window increases, for there to be more confusion, more just less focus. Just as, I hate to anthropomorphize these things, but the same for us. You throw a book at somebody, say, read the whole book, and I'm going to quiz you on it. You're going to have a lot less, targeted feedback on that than if I ask you a question about a very specific part.
Mm-hmm.
So that's a fundamental trade-off I don't think is really going away. The other thing is that, even when it's focused on a narrow part of the code, it's still ultimately a probabilistic system. So while the changes can be fantastic, I use these things like crazy. If you need to apply the same change across, again, thousands or tens of thousands of repositories, you really don't want to scale the human review of those changes to the number of changes that are being made.
Mm-hmm.
So at the end, what you really want is the actor to be deterministic, but building that machine or that cookie cutter that you can then go use to stamp out, low variability cookies across the code base itself can be developed with the assistance of an LLM.
Yeah, interesting. So where would you say the kind of solution lives then? Do you think, is it completely non-LLM? Is it somewhat between LLM and more traditional development?
It's really a mixture. So what I started working on 10 years ago with OpenRewrite was really a refactoring engine, and it's a program. So it has a deterministic output every time. It's has a unit testing framework to it and so forth to basically cover all the variations that are inherent in code. But it used to be that you would encounter problems like, say, I'm trying to move from one framework version to another, and I have to write out all these recipes. Mm-hmm. So for something like a Spring Boot 3 migration, for example, Spring Boot 3.4 migration, there's almost 3,400 recipes in the catalog right now to just deal with that migration.
And tell us what a recipe is. Maybe we'll go a little bit deeper into OpenRewrite now. What's the function of a recipe?
So a recipe is a program that makes a particular code change. That could be a dependency change. It could be a property change. It could be, this API change from this to that, and so if you imagine just kind of looking through the release notes of a change or an upgrade, each of the steps that's in that migration guide would be itself a distinct recipe that's operating in a larger composite recipe to accomplish that thing.
Gotcha. Okay, so if there's a couple of steps there. If you feel like you're going from version X to version X plus 1, you need to first of all identify what are the recipes that you need to think about, and are those instances of that code that you're actually making changes to, does that trigger certain recipes that you actually need to perform an action, I presume?
That's right. And so the historically for us, we have thousands of open source recipes. If the problem statement that you have happens to fit well to the catalog that we have, great. You can kind of ready to go get value right now. If there's some custom change you want to make, that's going to involve writing new recipes. And so the perceived cost of writing new recipes used to be, well, I have to learn how to write with the framework, and I have to I just have to spend time doing it. And whether it was worth writing recipes or not, there was like a diminishing return to it. It really depended on how many changes that you had to make, and was it 60? Was it 60,000? And is it worth it or not? And what I'm seeing, I think, with LLMs right now is that the cost to write net new custom recipes is approaching zero. So as one example, just a few days ago, I was talking with a banking engineering executive that actually literally described this problem to me. They said, I'm trying to move from on-prem infrastructure to container-based infrastructure. Key problem is right now, a lot of these applications are writing files to log or logs to files. Instead, they have to be written to sysout because we have a Splunk agent that's connected to these containers. And so that will scoop up sysout and send it on to Splunk. I literally just kind of transcribed what he was saying in just a paragraph and said, go plan the recipes, go write them. And in the back of my mind, I thought, well, I know, been around software long enough. I know that this is just going to be a lot of logging configuration changes. Like you're going to have to change a logback configuration, you have to change a log4j configuration. But what are all the variations of this that I'm going to have to accommodate? And sure enough, like a Claude code would just go out and make a plan of 6 or 10 or 15 steps and just start knocking out the recipes.
Yeah.
Because OpenRewrite has a very declarative framework, it's like, you assert before after text in the code. It's hard for the model to cheat at the test. It just writes this test before after. And then it works hard to make that test pass because the test itself is somewhat inflexible. So it's interesting that, as we think about like writing frameworks like this, the more declarative we make our tests, the better the outcome is in the main source code.
So would you have the LLM write the tests as well as run them as well, or how does
so the LLM came up with 6 or 10 steps, whatever the case might be, and its first move then is going to say, this is what logback configuration looks like before and after, and this is log4j configuration before and after, and so it writes out all the tests, and then it starts working on the main source code of the recipes, working until those tests pass, essentially. So it was about 20 minutes from me transcribing this message to I had the first 6 functional recipes. We deployed that to that tenant and ran it on nearly 10,000 repositories. And here's all the applications that would have to change and how many of them use this versus that. And, then you can kind of, now it becomes a feedback cycle of, do I like the change? Is there anything missing? Is there, and you just feed that back into the LLM. I didn't like this change. Go change this. I didn't like this change. Go change this. And it iterates on the recipe further.
It's interesting because I guess there are going to be very often some minor specifics where actually you might want to do something slightly different. Is that a manual review, or are there ways in which you've used other technology to more be a judge for those kind of reviews?
It depends on the type of change. So for us, and this is going to sound strange, but we have a recipe, actually an OpenRewrite recipe, that itself is something we call compilation verification, which we will run some other set of recipes, and then we'll just verify that the compiler would pass on that file after the change. That's actually doesn't require the whole build to run, so there's some special sauce to how that particular recipe works. But that itself is a judge. So, I can basically work through the release notes, making all the changes, and see at the end whether I've missed something or I've just done something wrong. And then that becomes this kind of cycle that the LLM can feed off of itself. Mm-hmm. There's, of course, going to be a lot of changes, especially configuration type changes that are not verifiable with just compilation or even running unit tests in many cases.
Absolutely. In my mind, I'm thinking, this sounds great. But then once you do this across scale, across a ton of different repositories and projects, does this then start creating pull requests in every single project? And then, who then goes about merging all of those pull requests in unison than anything? What's the logistics, I guess, of actually then pushing this into more of a production build?
This is such a great question. And indeed, I think most people that start thinking about large scale change, the most natural thing for us to think of as developers is pull requests or mass pull requests. Mm-hmm. I think we've identified over the years the room for something we call pull-based change and room for something, like you actually use the right word, push-based change like this. In general, my observation about the social dynamics of mass pull requests is that when a product team receives pull requests from some central team, they view it kind of like unwelcome advice coming from an in-law. They're just looking for a reason to reject it. I mean, you can imagine you're at that holiday table and your, mother-in-law's like, oh, you got too many pounds on you right now. I think you could do something about that. You're gonna be like, hey, like I'm busy. Like it's, I'm getting older. You're trying to make excuses. You're trying to. However, if you look at yourself in the mirror and you think, it's time, I'm ready to start, hitting the gym. You're just more naturally likely to take that advice.
Yeah.
And so we really focus a lot on how do we put the problem in front of a developer in the kind of IDP sort of way. Like, here's where you're at relative to an objective, but it's meant as to be informative. And here's the button. At a moment in time of your convenience, this recipe is ready for you. And we got you 99% of the way there, 95% of the way there, whatever the case might be. Do it. And so what you'll see is individual product teams doing pull requests to their subset of the business. And that has a much higher acceptance rate than a centrally issued mass PR.
And when the pull requests are created, is there typically no work that needs to be done, or is there a kind of like a certain weight that comes with every single pull request, whereby development teams will need to, at the minimum, I guess, do some kind of a review, but also maybe make changes? What's the fixed cost, I guess?
It very much depends on the change. So something like a log for shell event is where this vulnerability, high impact, we need to get it done now, short timetable. That's actually something that's good for push-based change. That's going to be top-down driven. Somebody mass issues PRs to everyone. There's somebody kind of like with the clipboard making sure everybody's done. But the review of that is pretty simple. It's going to make the same kind of change everywhere. Once you see one of them, you just kind of mass commit them. You don't look at every individual change. So that's one of those things that gets through quickly. We have other kinds of changes, like I think about dependency vulnerability repair, and bumping both direct and transitive dependencies, whose vulnerability fixes are only a patch version away from the minor release I'm already on. Those are things let's just push through, right?
Yeah.
And almost automate the push through of that. However, if the fix is a minor version away from the patch or the minor I'm already on, now it's a little more situational. Like, Jackson makes minor release changes that the app may not be functional. Yeah. So you've actually got the same recipe running in two different configurations, one of which is fully automated and one of which is maybe a little less frequent. Maybe we do it once a week and requires a little bit of human review.
Yeah.
And so that's okay. We just do that a little bit differently.
Yeah, it was funny actually, because when you were talking about the capabilities there, my mind immediately did think security issues. A developer gets my background in Sneak, of course, whereby developers are told there's a vulnerability at this level in this transitive, maybe this is the version of the direct you need to upgrade in order to consume that fix. From a developer's point of view, it's almost distraction, and the more you can do to ease that ability to say, look, to get security off your back, or to get to eliminate this backlog of issues, we've come 99% of the way to fixing this for you with a level of confidence that you can feel good that this isn't going to break anything. It's been tested and those types of things. That seems like a really super valuable use case.
It's one of the pillars. Yeah. So I think application modernization, security vulnerability repair, those are two key pillars and ones that we've known about for a long time. Mm-hmm. Maybe to transition to the third one, and this is the one that's a little more surprising, I think, is this large scale impact analysis. And so when I first started OpenRewrite, it was all about making a code change. I hadn't even imagined the kind of large scale search or impact analysis use case yet. Mm-hmm. And so we came to understand this even, I think, 1 or 2 years into Moderne's existence, that a recipe could, in addition to making a code change, just mark something as found. I found this thing right here. So maybe then I'm doing a search for a particular use of a API, and I'm going to find all of those. And I'm able to use the richness that's in that lossless semantic tree. It's not just the abstract syntax tree, but it's everything the compiler knows, all the transitive dependencies. So I really can accurately identify every single use case of a particular API. Mm-hmm. And then there was one step beyond that, which was, well, it's great looking at all the individual search results, but I'm trying to get a holistic view of what these call sites look like across, again, thousands of repositories. So at that point, OpenRewrite accrued a piece of functionality called data tables, which is just recipes can emit a row of data with columns according to a schema the recipe's choosing. And if you imagine this, recipes are running on many different repositories, and each of them is contributing rows to the same aggregated table, then when I'm looking for, say, like an API like that, the end result is a table, CSV, or an Excel file or whatever, which is just the inventory of every single occurrence of this and what repository it existed in, what business unit it was in. And so recipes more and more, even if they were making changes, started producing these data tables as well, just because that was useful. Then we turn the table to, or turn the clock to 2024, and tool function calling comes about with large language models. And we suddenly recognize that we have in our possession, or the community's possession here, thousands of these recipes that are producing data tables of various sorts. And if we improve the description text on those recipes, we can basically bolt all those recipes to a model as tools and say, hey, when you have a question about the code at large, not just the code you're looking at right now, ask me. Just ask me if there's a recipe or series of recipes that would help you answer that question. And so a model is able to read the recipe description and its option descriptions and its data tables and what they mean, select one, run it, get the output, and then pre-aggregate that in some way to surface some result. This has been the sort of big sea change, I think, in our the last 8 or 9 months at this point.
That sounds really powerful. So you essentially have a mapping then between a kind of effectively an LLM tool directly to a recipe that can exist in a project or repo for the code in that repo. So then, if I was to ask questions of the code or of your project, the LLM will have deep insights into where certain things are being used, how they can be changed as well.
Right.
And you expose this is effectively exposed via an MCP server. Is that right?
That's right. Yeah. So it's both. It's we kind of expose a direct chat experience to say, just ask a question about the code. Again, not just one repository, potentially. At one of our largest customers, it's nearly 5 billion lines of source code under management. So that's the context we're dealing with, is like 5 billion lines of source code. You could just ask this question, but you can then also expose it as an MCP server. And the key use case there is when I'm in a Claude Code or something like that. Say I'm like I had an example last week. I'm in a microservice. I want to add a middleware cache to this microservice. I know I use middleware caches in a bunch of other services, and I want to use the same sort of pattern I use everywhere else. So when I say, add a middleware cache, please make it consistent with the rest of my code base. Well, Claude's training set doesn't know what's consistent in the rest of my code base, nor does looking at that one repository, which lacks a middleware cache now, it can't infer that from the code as it is. And so that's an example of where Claude then reaches out to that MCP server and says, go find me all the places where, this type of middleware cache is used and give me the examples. And so it'll then pull examples one at a time from different repositories and use that to inform it how to develop that new code over here. Really interesting.
Yeah, absolutely. And from the agentic point of view, where you kind of like have, agents kind of like asking these questions, thinking about it more, and having this available to those agents is it's going to provide more valid and correct answers as it creates. What about if we was to look at more kind of like open source? So obviously there's going to be a number of things which we'll be consuming from open source, as well as our internal projects and repos. Is there support available for being able to analyze and look at other projects in and around the open as well?
Yeah. So for our customers, we'll do what we call mass ingestion. We'll ingest their whole code base in the form of these lossless semantic tree artifacts. And so that's really the same data model that open source OpenRewrite uses, but serialized to disk. And so these MCP servers and so forth are able to operate on vast business units rather than just kind of like going through and parsing each one at a time. That same thing that we're doing for private code, we've done for close to 4 billion lines now of open source code. So we run that service, just app.moderne.io, as a kind of a free service to anybody. Just it's just available via GraphQL API and so forth. So yes, in this case, the model is able to always look at proprietary code and open source code to the extent that we know about it. Equivalently.
Yeah, sounds good. And going forward, I guess thinking further out into the distance, whereby prompts turn into specs and things like that. What's I guess your more longer term vision of how as AI becomes more capable, as people will be able to lean more into AI, how do you see that working with things like OpenRewrite?
I think the key value here for us has always been this data about code that's not just at the syntax tree level or the text level, but everything the compiler knows. And that's unfortunately a very difficult problem to produce, because you have to side inject yourself into the compiler to get that data out, and how even to invoke the compiler for an arbitrary enterprise repository is a very layered problem, I would say. So I don't think the value of that data, essentially like data lake of deep like code data, is going to go away. The kinds of ways we apply it are going to continue to change. And this example here of, allowing, say, a coding agent to look up the way code is used elsewhere is just one new use case I wouldn't have imagined a year or two ago. But as for spec-driven development right now, I think that day feels like it's here, right? It's already a reality. It's definitely how I use coding agents. I always ask them to write out a plan, to make that plan, to reify it on disk, so it's not just in its memory, to continue to edit that plan as it moves along. More recently, I've started to think, well, sure, put the plan on disk, but when I'm doing something new and something cool, I have it write the plan to disk. I git submodule clone our documentation into that repository, and I say, if there's room to update the documentation with this, go ahead and do that too. And then the last thing is to have it writing a blog post as we're working on this feature together. So it's really doing 3 different activities: updating documentation, writing that blog post that's going to explain our work together, and also maintaining a detailed plan about what we're going to do and what we've done.
Yeah, and it seems to me almost like the code generation still needs to happen, and it seems like you're injected at that stage whereby when the LLM needs to make decisions about what to build, what to write, how to make changes, how to upgrade versions, and things like that. That's where it's automatically injected, and it's using Moderne or OpenRewrite there at the source. Awesome. Any next steps in terms of what's next? What are the biggest challenges right now for you, and what's next?
For me, I think the big responsibility that's on our shoulders is to expand that lake. So it's always adding new languages, really deeply integrating with their tooling and their compilers, and just extracting as much density of information as we can out of them. So one of the really interesting and surprising results of the last couple of years has been, as we've added new languages like JavaScript and Python and C#, we discovered that the loss of semantic tree model for those is highly overlapping with the Java original loss of semantic tree, to the point where we actually have them extend the base JLST that's formed our Java capability to this point. What that leads to then is that some recipes we originally wrote for Java automatically work on C# and Python and JavaScript in a really surprising way. So think about a search recipe called find SQL, which is just looking for string literals that have SQL in them, or binary concatenations of literals. Or when we wrote that originally for Java, because JavaScript, Python, and C# extend from J and use the same j.literal construct, that recipe actually works there as well. So every time we add a new language, it's like flipping on a light switch on another corner of the world that we didn't look at before. And to me, that's a big part of our roadmap, is just continue to turn the lights on more and more places.
Yeah, awesome. For people who wanted to try it out, obviously you mentioned OpenRewrite is open source, so people can
That's right.
People can have a play with that and Moderne.
Yeah, absolutely. Our site moderne.ai has, of course, references to the OpenRewrite docs as well, along with a number of other materials. And if you want to go straight to OpenRewrite, just docs.openrewrite.org.
Awesome. Wonderful. Well, Jonathan, it's been a real pleasure, actually. Very insightful. Thank you for going deeper with us on some of these problems. Yeah, feel free to jump to some of those links for those who are listening. And we really appreciate your time, Jonathan.
Thank you.
Awesome. Thanks for listening, everyone, and tune into the next episode.